Hi. So this is a problem that was suggested to me by one of my students. He has a doubt where this is a definite integral from 0 to 1 of sine inverse x by x dx, right? So let's try it out and see how we can solve this. The first thing that comes to mind is put the substitution x is equal to sine u here, and dx will become basically cos u du, and therefore the integral becomes, if x is 0, u is 0, if x is 1, u is pi by 2. So 0 to pi by 2 u cosine inverse sine u, and dx becomes cos u du by denominator is sine u, right? This is my integral, and this is the same as the original one. And what I will do is I'll do integration by parts here. So this part can be easily integrated. So I'll use that as the second function. So integration by parts implies that this becomes I is equal to u into ln sine u. That is the integration of cos u by sine u du, and evaluated from 0 to pi by 2 minus integral 0 to pi by 2 differentiation of u and ln sine u. This is just integration by parts. If you put the value here, notice that when this is pi by 2, this is ln 1, so this becomes 0. And when it is 0, you are multiplying something with 0, so that is 0. So this part totally vanishes. So my integral I is basically equal to negative of 0 to pi by 2, 0 to pi by 2 ln sine u du, right? So we have to find this integral actually now, right? So how do we find this integral? Let's work on it. So let's say I1, let's call this part without the negative sign I1 as integral 0 to pi by 2 ln sine u du. Now clearly we can apply the property that I1 is equal to 0 to pi by 2 ln sine of pi by 2 plus 0 minus u, pi by 2 minus u du. So this is equal to 0 to pi by 2 ln cos u, right? So I1 is the same, ln sine u integral is the same as the ln cos u integral. So adding both of them, you get 2I1 is equal to 0 to pi by 2 ln sine u cos u, ln sine u cos u du, and this is half sine 2u, half sine 2u du. This is equal to 2I1, right? So I'll do it on the next page. So basically, I'm going to try and get it back in terms of I only, right? So 2I1 is equal to this. So half integral 0 to pi by 2 ln half sine 2u, right? So I'll just write it here. 2I1 is equal to 0 to pi by 2 integral half sine 2u, so ln half plus ln sine 2u du. So split it apart, do it separately. You get ln half into pi by 2 after evaluating the integral plus 0 to pi by 2 ln sine 2u du, right? Okay, great. So now let's do this integral. Let's call that I2, right? So what is I2? I2 is equal to integral 0 to pi by 2 ln sine 2u du. Put the substitution 2u is equal to z. So 2 du is equal to dz. So what we get is integral ln sine z dz by 2, and from 0 to, if z, u is 0, z is 0, if u is pi by 2, this is pi, right? So I2 is the same as 0 to pi, this thing. So it is half of 0 to pi ln sine z dz, right? Now we have a property of an integral, definite integral. The property looks like this. If it is 0 to 2a fx dx, it will be equal to integral 0 to a fx dx plus integral 0 to a f of 2 minus f of 2a minus x dx. So this property we'll utilize here because I want to convert it into 0 to pi by 2 because that was my initial I1 and all. So I2 will be equal to half of this integral. I'll split into two parts, 0 to pi by 2 ln sine z dz plus 0 to pi by 2 ln sine pi minus z, which is same as sine z dz, right? So clearly you're getting 2 times ln sine z dz. So I2 is equal to half into 2 times integral 0 to pi by 2 ln sine z dz. This is my I2. So basically I2 is equal to half and 2 cancel. It is equal to 0 to pi by 2 ln sine z dz, right? So remember that this I1, 2I1 was equal to this, right? And what was our I1, right? I1 was basically integral 0 to pi by 2 ln sine z, right? ln sine u du. This was my I1 initially when I had written, right? So that means that basically this I2 is equal to I1, right? This is I1 only. So what happens here is ln half into pi by 2 plus I1, right? And then I1, 2I1 is equal to this. So therefore I1 is becoming ln half pi by 2, right? 2I1 was equal to ln half into pi by 2 plus I1 because we proved that I2 was equal to I1. You should go back to the video if you're forgetting what is I1 and I2. I'm saying that because I'm also forgetting a little bit, but I'm sure this is working out now. So I1 is equal to ln half pi by 2, and that is basically minus ln 2 into pi by 2, right? Okay, and remember that the initial integral was after doing integration by parts, we got 0 here, and we got minus something here, right? 0 to pi by 2 ln sine u du. This was what you got initially, and this is what we called as I1. So therefore, you get minus, and this value I1 we know now, minus ln2 pi by 2. So your answer should be pi by 2 ln2, right? Pi by 2 ln2, the value of pi by 2 ln2 comes out to be around 1.0887, around 1.088087 if you check in a calculator. So that is my integral. So basically the answer of integral 0 to 1 sine inverse x by x dx comes out to be pi by 2 ln2. And we did that by first doing integration by parts and then applying a couple of times the properties of definite integrals. I hope you understood the solution. I'll be back with more videos. If you like the channel and like the content here, please like and share and subscribe. See you next time.